Okay, I want to talk in this screencast about classification of functions, and what we're going to cover these concepts here. We're going to cover the many to one function. We're going to cover the one to one function. We're going to have a look at odd and even functions, odd and even functions. So that's in this lesson. Okay, so far we've had a look at functions, and we've had a look at what defines a function, the vertical line test, domain range. Had a look at, in the last lesson, lots of different types of functions: the hybrid, the rational, the radical, and that other one, the absolute value. That's the one. So this is where we're up to. Let's look firstly at the many to one function. So and the one to one. So really these two are linked. A function is either many to one or one to one. And what this many to one means, we're looking at how a function's range is mapped to its domain. So I'll give you an example of a many to one function, and that will be something like this, where for a particular y value, let's have a look at this particular y value here, then there is more than one x value that maps to. So that's called a many to one function. In fact, we're going to here, in that case, there are three. Now there are some y values that only have one. There might be some that have two. Yes, there'll be one that has two when you hit this tangent here. This one's got three. If it's more than one, it's a many to one function. So this is a many to one function. A many to one function has more than one x value in its domain for a particular y value in its range. Okay, so this, you can think of this as we've had the vertical line test. This is the horizontal line test. The horizontal line test will test whether we've got a many to one, or in fact a one to one, which is logically enough, when we throw the horizontal line test through, it only cuts once. So we'll have a look at an example of a one to one. That's going to be a straight line. It's not going to be this guy, the parabola, is it? But it'll be half that parabola will be fine. Indeed, half this. What's this? Or the exponential? How about we look at the exponential curve? So that's y equals a to the power of x, and that is a one-to-one function because we only ever get a maximum of one strike. So this is a one-to-one function. Okay, now you might be asking, why are we talking about this? What's the point? And that's a very good question. I would hold off on answering that in any great detail at the moment. I would just say that it's what we're going to look at in a couple of lessons' time are inverse functions. And when we find the inverse of a function, if it's many to one, it'll turn into a it won't be a function once it's been inversed. So the horizontal line test actually becomes the vertical line test. So if it fails the horizontal, once it's been inverted, or that's probably the wrong terminology, once we found the inverse function, then it will fail the vertical line test. So in summary, a one-to-one function will have an inverse function. If it's a many to one, it won't have an inverse function. More on inverse functions later. Right, let's have a look at odd and even functions. So that's just some notes, and we can talk a little bit more about that in class. So let's have a look now at odd and even functions. Okay, now we're going to have a look at this, and there are symmetrical properties to these concepts. And what we'll do is have a look firstly at even functions. Now, an even function is defined as being symmetrical about the y-axis. So if we have a look at our old favorite y equals x squared, that has line symmetry about the y-axis, and therefore it is an even function because it is symmetrical about the y-axis. And what we can say is that for a function's negative value, it will be the same as the function's positive value. So what we can take here, if this is our value of x, right, then that's fx, it's just going to have the same value as minus x. So if that's x, that's minus x, its function values are the same. So this is f of x, right, just there, which is the same as, oh, I beg your pardon, why am I going in there? That was a mistake. Which is the same as f. Oh, you're joking. As I keep hitting something there, and I apologise for it. I'll work this new computer out at some point. So f of x and f of minus x are the same. That's an even function. So where we put in a value in the domain for x, and we put in its negative value, we get the same function value, defined as an even function. Okay, that's an even function. We're going to have a look at an odd function, which does the following. Okay, so for every, all right, let's have a look here. For an x point in our domain, we get a function value of x. Now what happens here, again, I apologize. What happens here is that for minus x, if we get the negative of the function value that we got for x, right, so it goes down here, and if that is the case for all these points, then we'll have what's called point symmetry or rotational symmetry around the origin. So this here is a very pretty, this is a y equals, what is this? This is y equals x cubed, isn't it? Y equals x cubed is an odd function, because as it is symmetrical, so I'm going to talk in terms of geometry, symmetry is symmetrical, which is rotational, about the origin. And what we find here is that f of minus x is equal to the negative of f of x. So this is our identifier for odd and even functions. So in an algebraic sense and in a graphical sense. So in a graphical sense, even, symmetrical over the y-axis. Why does that happen? Is it when I hit that? What is it that I'm hitting? I'll work it out. So symmetrical about the y-axis, line symmetry, symmetrical about the y-axis, that makes it even. Point symmetry or rotational symmetry around the origin gives us an odd function, and in terms of its algebra, when we sub in minus x, we get minus f of x. So let's have a look at an example or two. Okay, so in these examples, determine, I'll just write this out, so I'll pause for a sec. Okay, so the questions here we're looking at, determine algebraically if the following functions are even, odd, or neither. So algebraically, we are simply going to find the function value at minus x. So we've got the function value at x defined here. What I need to do is find out what the function value of minus x is. So I simply put minus x in here. You'll see that what will happen is you square minus x and you just end up with x squared. minus 3x squared plus 5. Look at that. It's exactly the same as the function of x. So therefore that function is an even one. And if you think about it, it's just one of these, isn't it? It's a concave down through 5, so it just does this, and it's symmetrical about the y-axis. Okay, let's go over here and have a look at this one. G of x is a cubic. So let's find out what g of minus x is. We put minus x in here and cube it, and then we put in minus x in here. So we end up with minus x cubed, which is minus x cubed, and this is minus 3x. I reckon that is just the minus of x cubed plus 3x, which is the minus of gx, isn't it? Minus of gx, and if that's the case, then it's an odd function. So it's got that point symmetry around the origin. Down here to a hybrid, same. We're going to put in h of minus x. We're going to see what we get. So h of minus x, let's put it into, doesn't matter which one we put it into actually. What we want to see is what comes out at the other end. So I'm going to put in minus x here for x. So using this definition here and squaring it. And if I do that, I end up with x squared minus 2x pi plus pi squared, and that's equal to, I think, x minus pi, isn't it, all squared? X minus pi all squared, which is equal to the negative of h of x, minus of h of x, because if you have a look here, if you minus hx here, then you end up with x minus pi all squared positive. So h minus x is equal to that, so it's an odd function. If I'd started with this one down here, if I'd punched in minus x there, I'd have got minus x minus pi there, beg your pardon. So the minus x goes in there, and we put in a minus pi, we square it. So this becomes minus x squared plus 2x pi, plus pi squared, which is minus, this is x plus pi all squared, which is minus h of x. So whichever one you start with, minus h of x, you end up with the negative of the other part of the hybrid function, and that shows that it's odd. Okay, so let's get that'll get us through the next little section. Classification. Just to recap, one-to-one functions pass the horizontal line test, which mean eventually when we look at inverse functions they will have an inverse function. A many-to-one function doesn't. Odd and even functions are tested symmetrically. Even functions about the y-axis, odd functions point symmetry about the origin, and algebraically by finding out the function value of minus x. If it's the same, it's unchanged, it's even. If it's the negative of what you started with, it's odd. Okay, I'll leave it there and I'll see you in class.